Yeah, so the practice problems are going to be a lot easier. Okay. Sorry, the practice problems are going to be more difficult than what was on the exam. And yes, there was a lot of emphasis on what we were doing in on the Monte Carlo, but it's only in the exam because first off, when I wrote the exam, I had to do it in the old format, switching back to the old format, just simply for on Canvas, which means nothing to you, just other than it will look a bit different. But otherwise, you'll still submit things the same way you did previously. So no worries on your end for that. So, but it meant that I had to score it out of 117. Sorry, not 117. I had to score it out of 70 points, which meant that since it's out of 70 points, I think I've got 4 problems worth 15 points and 1 problem worth 10. So, all right. So on the practice exam, we have make username, we have XOR, which is exclusive OR. We have sum of threes, we have all digits products, has 2, 3, 1. Really not at this point. Plugged it in. There we go. 2, 3, 1. And yeah. So for the Monte Carlo operation on the exam, expect it's either going to be a 6-sided die, rolling 6-sided dice, or rolling or doing coin flips. Okay, so nothing more crazy than that. Okay, so I had all this stuff over here because because this was the template I used for an exam that had regular expressions in it. So ignore the regular expression notes. You don't need them here. Okay. All right. So write a function called make username that generates a username for a given name and a suffix, as demonstrated in the examples below. And I always like to give you the examples because I find that helps really remove the ambiguity. You can assume that the format of the name is either first name, last name, or first name, middle name, last name. And I'm sorry if I haven't, by the way, I'm sorry if I haven't responded to your emails over this past week. It has been a lot of stuff with getting the exam ready and also end of semester stuff that I've just had to take care of. So if I haven't responded to you, feel free to reach out again if I don't reach out back to you. All right. So it's in either first name, last name, or first name, middle name, last name. And yeah, although this is not true for all cases in real life, that's a link about falsehoods programmers believe about names, which is a very fun and very important read. Because a lot of times with inputs and stuff, you have to worry about your assumptions, and there's things about names, such as people's names are written in ASCII, people's names are written in a single character set. They're not written in all caps. They don't contain, people's names are case sensitive or case sensitive. My wife has a hyphen in her first name and no middle name, which makes her name which leads to such interesting things happening during input, name inputs and stuff like that. Okay. Anyway, point being, we're just assuming that this fits it. So here, Andrew Rosen in the input 12 becomes AR12. Alan Turing in 5 becomes AT5. Andrew Benjamin Rosen would become ABR3, and 3 would be ABR3. Andrew Benjamin Rosen and 104 would become ABR 104. So fairly straightforward function, I think, to write. Let's go ahead and copy this. Hit new. And now we can paste this into here. That worked really well, other than the ticks being copied wrong, but whatever. Okay. So make username. So for this, we have to we got to take our string and we split it up, and they guarantee that it's going to be I guarantee it's either going to be made of 2 things or 3 things. We can either So we can write an if statement for that if we want to. But honestly, we don't need to. We can just split it into, we can write it very simply with, let's see. So first off, we'll create something called username is equal to empty string. We'll return that username at the end. Parts is equal to name dot split. And then for name in part, so for each of those names, we just need the first character, right? So user name dot username is equal to plus equals name 0. I'm going to go back and fix some other stuff in this too. Just give me a sec. But for username parts and parts of split, for name in part, username name 0, and then we do username plus equals, and we need to convert that into a string here. And there we go. The only thing that's going to, well, it's almost completely correct in terms of matching my outputs. But if I do print, make username Andrew Rosen 3, we'll see that if I run this, that I get that. Okay, fine. I'll save it. Exam, review 3. Part is not defined. Did you mean parts? Yep. Okay, totally. And it gives me capital A, capital R3 because Andrew and Rosen are capitalized, but it wants lowercase. So it's just simply to transform it into lowercase before we go on, we can say, oh yeah, let's go into name is equal to name dot lower, I believe. And then let's also change this over here since we have name as a variable. Let's avoid name collision. So we'll call it name part over here and just replace it over here. And that isn't anything to have to do with correctness more than neatness. All right. Problem 2. XOR. This one's actually pretty fun because there's a lot of ways to solve this one, including a one-line solution. XOR is, so we learned about 2 logical operations in this class. Specifically, we learned about the and we learned about the or operation. The XOR operation is our conversational or. It's the exclusive or, meaning it can be one or the other, but not both. Do you want to go to the movies or do you want to go to the beach? We can't be in 2 places at once. Do you want to have pizza for dinner or do you want to have pasta for dinner? You know, do you want to go to vacation do you want to go to vacation on the East Coast or the West Coast? Can't be in 2 places at once. So exclusive or has two possible, so meaning only, so an exclusive or, where if you have or, the truth table for or looks something like this, where basically if you have A, B, so if A is, so if you have true or true, that will yield true, or false will yield true, false or true will yield true. And you only get, and for an or, you get a false here. Remember, so for this one with an or, if one of them is true, the whole thing is true. Okay. For an exclusive OR, we change that again, we change that up. Where it's only true, it's true if and only if one of the things is true. So here, if both are true or both are false, right? Then then the entire answer is false. How did I phrase it here? Return true if only A is true or only B is true, but false if both are true or both are false. So first way we can do that is that we can program that out. We can say, we can do all four of those possibilities, which is something that a lot of students do. If A equals true and B equals true, return false. And then we just simply copy paste this a lot and modify as needed for our four clauses. The advantage of this is that if you've got it all written down, it's kind of foolproof in terms of just making sure you covered every case. And doesn't require any additional kind of thinking about any tricks or anything like that. It is fairly straightforward. Right? You've went through all four possible scenarios and you've listed them out, so there's no way you missed anything. So that's one possible solution for this. Another possible solution that I like is that basically we can say is that we can kind of just simply say, oh, return true if only A is true or only B is true, but return true but false if both are true or both are false. So another way is we could kind of say, okay, instead we could do if A equals B, sorry, if A equals true and B equals true, and basically we could simply combine this first line and the second line into one statement. Or is false. I'm getting there. That being said, what we're doing over, and then what we could do over here is we could just simply cut this down. Right? Something like that. Where if they're both the same, then return, so if they're both true or they're both false, return false. Otherwise, return true. Which, wait a second, that's the same thing as asking, what if they're both the same? Which we could totally ask instead. And before I move on, these double equals trues over here are kind of unneeded. If A and B, if those convert to true, we can rewrite this if A or not A and not B. But sometimes it's just easier to see those written out like that. So what we observed over here is that if they're the same, we can just simply return false. If A equals B, return false. Else, return true. And finally, we can actually condense that even further by noting, okay, if they're the same, I want to return false. If they're not the same, I want to return true. And so our one-liner looks like this, as was noted in chat. Return A not equal to B. If they're not, which simply says if A and B are different, this will evaluate to true, and if A and B are false, it evaluates to false. There's a lot of thought that goes into this. Do we need parentheses for the third one? Wouldn't hurt, probably. because again, and ors have different orders of operation. I think the and has a higher precedence, but honestly, I forget. So I would totally put parentheses around. Okay. So that's enough about XOR. So with this, I can definitely assure you there's going to be a problem like this on the final exam where you're asked to iterate over a list of lists. So given a list that contains many lists of integers, return the sums of all the integers in the list that are multiples of 3. Half credit if given if the answer works on a list of integers. Right, so here we have a list of lists. Here we have a list of lists as well. And notice they're all different sizes. You can't really say, okay, it's split, it's grouped by 5s or grouped by 10s. No, all the lists are different sizes. So I'll go through the correct answer first, and then I'll show you what I mean by the half credit answer. Okay. And finally, right, these need to be commented out. So we've got our numbers. So for list of nums in numbers. So what we want to do over here is we want to iterate over that. But the first thing, of course, you should remember to do is set up a running sum. So total is equal to 0, return total. Okay. So now we've got a list of for each one of these lists. So now with this for loop, what I'm saying is for each one of these lists. For this first one, I'm saying for this entire list. For the second one, I'm saying give me this list, then this list, then this list, right? For each of those lists of numbers, for each n in list of numbers, so here we're saying give me the first list, then give me the first item in the first list, then give me the second item in the first list. Then this says move on to the second list. Then give me the first item in that list. Move on to the third list. Give me the first item in that third list, the second item, the third item, the fourth item, and the fifth item. So for each of those n's, we ask if it's divisible by 3 because that's what we're trying to do. We're trying to add up all the numbers divisible by 3. If n mod 3 equals 0, this is divisible by 3, total plus equals n. And that's essentially what I'm looking for over here. It's not a particularly hard problem as long as you're not too worried about understanding how nested lists work. And I'm not gonna nest lists more than one deep like this. I'm not gonna have lists of lists of lists of lists of lists. At that point, the proper thing is to abstract it into some kind of object, okay, at that point, that holds other objects. Otherwise, you're creating too much mental load for yourself. So sum of 3's for this one should give me 15. Because 15 is the only divisible number in there. And then if I go if we change this 1 to 3, it should give me to 24. I'm sorry, not 24, 1 to 3, right? Will give me 15 plus 3, which is 18. And then if I change this one to 12, 12 plus 15 gives me 27. So this should be 30 now. So it iterates all over all those numbers. The last one's supposed to return 81 instead of 30. Yes, it is, because 51 is divisible by 6. Sorry, divisible by 3. This number is divisible by 3, so yes, it should have given 81 back. That's a typo. I think I must have thought that 52 was divisible by 3, but it's not. This one is just simply one from the exam, but now in list format, right? All digit products, given a list of numbers, return the product of all the digits of all the numbers in the list. So here we're saying 1 times 2 times 3 times 4 times 5 is 120. Here we're saying 1 times 0 times 2 times 0 times 5 is going to be 0, because any number multiplied by itself is any number multiplied by 0 is 0. 4 times 4 times 1 times 2 times 3 times 1 times 1 times 2 is 192. So here we'll go ahead and do this one. All digit products. Okay, so for this one, what we do is that, again, we need to go for n in nums for each n in this list of numbers. What we have to do is go, let's see, total is equal to 1. Return total for n. So for each of these numbers, we got to figure out what the product of the digits of that number is. So, now again, we saw two answers on the exam, which were very common. The first was converting it, the very straightforward idea of converting it into a string. N is equal to strn, or digit in n, or more specifically, we saw this a lot correctly, which would make sure that if it was a negative number, we wouldn't have to deal with multiplying against the negative number there. So for str absolute value of n, for every digit in there, total times equals int digit. Is it the computer? Is that the most mathematically pure way to do it? No. Does it work? Probably. In the sense that I'll double check, but as long as I haven't made any really silly mistakes, this should totally work. I mean, I'm not going to say it works until I run it, because the one time I do say that, oh yeah, it's totally going to work, I probably will have forgotten an error like that, right? I'm not infallible. I make the same kind of mistakes as you. I just made them so many times that fixing them is second nature to me at this point. Okay, and there, 192. So here, for what I did, again, I simply said for each number and then for every digit in the number. Okay. The other way to do that, of course, is we can just simply say, while, we can say, first off, in case it's negative, I'll be paranoid and say n is equal to absolute value of n, right? Just simply to make it not negative. And then I can say while n is greater than 0, digit, the last digit of n is equal to, get the last digit, n is equal to n divided by 10, and then total times equals the digit. Very short. We've seen this answer before. Just now we just simply put a loop in another loop here. Kind of a loopception, I guess. All right. I have better memes on the exam, don't worry. Including one that will completely baffle non-English speakers non-native English speakers in an absurdity because they don't know about Buffalo. Or don't know yet. All right, so has 231. I'm just very happy to be able to share that with everybody again. It's very good. All right, has 231. This one is actually one of my favorite ones that I've written, mainly because it's simple once you understand. The idea is simple once you understand it, but it took me a lot of time to explain correctly, which is funny. Has 231. Given a list of numbers, return true if it follows a 231 problem, namely that the list has a value x, immediately followed by x plus 1, immediately followed by x minus 1. You don't have to print out what the numbers are, but I've listed them in the example outputs for extra credit. For extra clarity. 1, 2, 3, 4, 5 doesn't have the pattern. So here we have 74, 3, 4, 2, 74, 75, 2. This one has that pattern I'm looking for. It specifically has 3, 4, and 2. That satisfies the problem where x, so in this case, x would be equal to 3. Then it has 4, which is x plus 1, and 2, which is x minus 1. So 2, 3, 4. Then here, even clear, you have 0, 1, negative 1. Okay, so for each number, we want to check this. The number after it is the number after it more than 1, and the number after it 1 less. This is kind of it's an interesting one because what makes it because again, there's a lot of ways to iterate through this. You can iterate through using just your standard range, because you got to know what the index is. You got to know what the index is if you unless you're using slices. So you can just iterate through it normally like you would in any other language, check one ahead and 2 ahead. Or you could use slices, and as long as your slice has got at least 3 items in it, you can check it. So both approaches are both valid. Again, it's just a matter of, these are a lot of these problems are problems that came up when I was teaching in Java, and they for this, but at this level. So I mean, they still apply here. I kept out the ones that don't apply. All right. So so here it's just simply, we don't need a running total or anything, it's just return false. So what we can do over here is we can say for index in range, and what is the range of the index? It's called, and it's in range of length of R. So here I'm saying R, not because I want to be a pirate or anything, but again, because in Java, this problem originally came from Java. And the basic kind of collection of items in Java is not a list, it's called an array, and I sometimes call it R for short, because that's 2 key letters less. So just know that when I say R, it's just a list. Okay, and again, the name doesn't matter, but I figured I'd explain why I'm using such a weird name. Lists are in general more powerful arrays. Arrays and lists do work the same way. The big difference is that lists can grow to accommodate more items, right? A list can have a size 0, and then you can add items to it as you need to, and it will get bigger and bigger. With an array, you say an array is a container that holds so many numbers. So it has a static size that does not change. So if you make an array of size 10, then it can only ever have 10 items. Its length is always 10. You interact it with the same way. You write it the same way you would a list, like this, using the bracket notation, and you use the subscript notation just like you would in a list. It used the indexes the same way you would in a list. An array is just simply a static list, essentially, a statically sized list. Interesting to note, though, how do you make lists? They're built with arrays. And then whenever you're actually, and then it just hides the fact it's an array, and whenever it needs to build a bigger, whenever you run out of space in your underlying array, what does it do? It just cheats and makes us a new one and copies everything over. And that's like the first week of 2168 right there. That's how So anyway, so for index and length, so for every index in this, we can say, okay, the x is equal to r at I. Now, again, I've got an error in here if I were to keep going, which is that because I'm going to be looking ahead, I have to make sure I stop sooner. So x is that. And then, you know, I don't do myself any favors by saying it's the x plus 1 value or that after that, but I can say, and so I'll just simply say, give it good names instead. 1 ahead is equal to r I plus 1. 2 ahead is equal to r. You know, because and the reason that I name it like that is because if I say if it's like x plus 1 and x plus 2, I could get myself confused later once I get to 2 ahead, to the item 2 ahead, and it's supposed to be -1, but I'll do +2 instead because it said I wrote down +2. So it's just giving it a naming convention so I don't get myself more confused than I need to be. Okay. You don't want to be more confused than absolutely necessary. Okay, sorry. The indentation is off for some reason, so I'm going to go ahead and fix that because I am a stickler, even when I code about that kind of stuff. Good. Okay. So now I say if x is equal to, and this is where it gets tricky. It's you gotta want to say if x plus 1 is equal to array I plus, sorry, is equal to 1 ahead. And you don't have to extract them out in variables. You could just do it all in one line. If x plus 1 is equal to 1 ahead. So if this contains a value that's 1 greater than what I have here, and x minus 1 is equal to 2 ahead, return true. It contains it. Again, once again, you don't want to put an else right here because then you'd only check the first pairing. You just want to put a return false out over here to be the default kind of solution over here. And let's see. That returned 0. Oh, because I did all digits product. Of course it would do that. Yeah, but when you're testing, be sure to put, okay, the name I is undefined. Because I called it index right over here, not I. Again, some issues are just easy enough to fix and occur because the author here is typing and talking at the same time. Now, of course, if it doesn't have one of these things, this is why it's important to test on failure cases as well. It's actually a very important thing to always test your failure cases because here this will alert us to the fact that we've got our index out of bounds exception. So here we want to stop 2 ahead. Because we're looking 2 ahead, we want to make lower our length by 2. The other way to do this that occurred to me as I was looking at the problem, copying it over, was what if I don't want to deal with this array out of bounds exception and it gives me headaches every single time I have to think about it? And the answer is slices. So here, what I'm going to do is I'm going to completely rewrite it because I think it's worthwhile. But at the same time, I also don't want to run out of time to go over the more complicated problems we have over here. So let me just speed run it for a second. So same problem, except now we don't have to look ahead. And instead, what I'm going to do is I'm going to say my slice, my trio of numbers. I'm going to call it just trio because it's going to be 3 numbers. It's going to be R from index to to index plus 3. So it's going to be 3 items long, index 1 plus 1, index plus 2. If trio, if len of trio equals 3, then I'll just do everything I already did, except I'll replace, I will replace it here with trio 0, 1, 2, trio, whoops, trio. There we go. So what I did over, and this makes it work because if you try to slice out of bounds, you'll get a smaller slice. So here I'm just saying, is it the appropriate slice length? And then I can go with it. All right, going to move on because we want to get to the Monte Carlo because I'm sure that's where everybody is kind of doing that. Now, there will be a file reading question on the exam, but you've had plenty of practice with that. If you need more practice with the file reading than what I provided here, please go to, and then please go to the exercise I showed you on Runestone back on Tuesday, which is all the way down here, and try the first couple of problems on the Stack Overflow developer survey. That is a great file reading problem. Okay. So let's see, practice problems. Here we go. So this one is a problem called Penny's Game. It's a trolls game. The outcome of any fair coin toss has an equal chance of landing on heads or tails. So if I were to toss a coin 3 times in a row, there are 8 equally probable outcomes. This is not the lie. Okay, this is completely true. If I toss a coin 3 times in a row and I mark down the results, I get 3 results: head, 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 tail, head, tail, head, head, tail, 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 head, head, tail, head, tail, 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 head, and tail, 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 where H is heads and T is tails. So head, head, tail represents I throw a head, then I throw another head, then I throw a tail in that order, right? Because here, when I say there's 8 outcomes, there's 8 outcomes based on what order you throw things in, okay? So I'm going to challenge you to a coin flipping game for $100. You're going to choose a sequence, one of those 8 sequences, such as head, head, tail, and I'll choose one like tail, head, head. And then one of us will keep flipping the coin until one of our 3 flip sequences occurs. And whoever sequence shows up first wins. So examples of these are, we flip head, tail. If we keep flipping the coin and we get something random like this, head, tail, head, tail, head, tail, head, head. My selection was tail, head, head. The most recent throws were tail, head, head. So I won. That came up first. My sequence came up first. Yours didn't come up first, which was head, head, tail. So if you do head, head, tail, you win. Here I do tail, head, tail. If we flip the coin and it goes tail, head, tail, head, tail, head, head, I win. Because again, my sequence came up first, right? Everybody get that? And finally, head, 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 tail. That's your win because, I mean, after you've rolled 2 heads in a row, you roll the 3rd head. You can keep rolling heads all over you want, but as soon as it goes to tail, you win. Seems like a fair bet. After all those 8 outcomes are equally likely. But then you remember that I mentioned that I was sorted into Slytherin and is a bit of a trickster. So he probably would be challenging you unless he was sure that was going to win. So let's write a program on the next page to simulate this game and see if your professor's trying to scam you. He is trying to scam you here. This is called Penny's Game, and the way it works is that once we've constructed the game, which is we flip sequences until something's occurred, we've changed the statistics. We flip until if we're flipping 3 coins in a row and just grouping them by threes, sure. But here we're flipping a coin until the 3 most recent throws are is the outcome of the game. So the idea here is that I make you choose first, and then I can just simply you simply put, my chances of winning go up if you choose your first choice, your second choice, and third choice. If I make my choice the inverse of your second choice, and then the same as your first choice and second choice, then I dominate your odds heavily. It means that the game gets really rigged in my favor. I've linked a video in the description if you want to watch it. It's by Numberphile. It's fantastic. So let's code it up and show what I mean by this. So we'll first let's go ahead and make a function called, I'm not going to call it game because we're going to be doing a lot of games today. So I'm going to call it penny. And it's just going to simulate one instance of this game. Let's also go ahead, and before we do that, let's go through the trouble of deciding how we're going to flip a coin. Okay. Obviously, we should import random to do this, right? So we can flip a coin in basically doing one of two ways, which is basically saying something along the lines of if random dot random, which generates a random number, like a random floating point number between 0 and 1, equally distributed. I can say if it's less than half, give me one value. If it's greater than 1/2, give me, so if it's less than half, give me tails. If it's half or greater, give me heads, right? So that's one way to do it. But when I'm dealing with like named things like heads and tails and not numbers, I really like random.choice. Okay. So I'll just simply even write this I'll make this a one-liner. Very simple. Return random.choice, and then I give it a list of things to choose from. My first choice will be heads, and then my second choice will be tails, a H or a T. Make sense? So random.choice is really useful, but there's nothing stopping you from doing this numerically. And you might have to in some other languages that don't include a random.choice or an equivalent. Looking at UC, making me have to work for everything. All right, so to do this now, we have basically, let's go ahead and write our, let's write a variable called our flips, which is, let's call it our history rather than, that way it doesn't cludge with our namespace of flip. Okay, our history is this, and what we care about is our three most recent flips. Okay, so let's go ahead and actually, we can actually like initialize it like this: flip, flip, and flip. Give it 3 flips to begin with, right? I know that seems weird, and the reason we're doing that is because I'm just simply making it easy to start rather than writing a for loop to do it. And appending the result. I'm just gonna do that here. Okay. Okay. And we can see here that head, tail, it's not the same thing each time. Head, tail, head, tail, head, tail. And yes, head, tail came up a bunch. That's nothing necessarily to note. Nothing special. That, statistical oddities happen all the time around you. You just never pay attention to them until you're actually talking about statistics or trying to roll your dice. Long story short, we have a history. Okay, now let's go ahead and so now the other thing we'll do is we'll start this. We'll have sequence 1 and sequence 2, right? The idea here with the problem is that write a program that simulates a game with one player trying to get head, head, tail, and the other trying to get tail, head, head. So we'll feed in what the two winning sequences are, so I don't have to remember, and so we can also try other things. Head, head, tail, tail, head, head. In fact, because this is and again, I'm just like doing this, because we're looking for head, head, tail, tail, head, head. Head, head, tail, tail, head, head. Because we're looking for like a string, it's actually easier if rather than storing this as a list, I go ahead and store this as a string. And so now instead our output looks like this, which is the same thing, but now it's not a list, it's instead there. Now, how is this going to work? I'm going to check, I'm going to simply create a while loop like this. While true. Yeah, why not? I can do this as a while, yeah. Okay. While the last, so what we're going to do is we're going to check the last three things in the history. While history -3 to the end is not equal to sequence 1, and same deal, but sequence 2. So while the last three characters aren't equal to one of our sequences, do another flip and add it to our history. And we can run it now, and we can see that it will run until we got tail, head, head, or head, head, tail. Tail, head, head, tail, head, head, tail, head, head. Boy, tail, head, head is winning a lot. Tail, head, head. Those times it doesn't run is because we got head, head, tail, or tail, head, head right off the bat. So, which is going to happen a quarter of the time if you think about it. So now let's go ahead and collate our results. Which is, we'll simply say return if player 1 won. So this will be true if player 1 won, and it'll be false if player 2 won. Okay. So def eval penny. Okay, so we're going to evaluate, let's call it simulate penny. Okay, so wins is equal to 0 for I in range. And then I'll just put in manually 10,000 games. We'll just do 10,000 games of this. If penny, so if it's true, that will be true. It will be a win. So plus equals 1. Plus equals 1. There we go. And there's no need for an else statement because we don't need that. Instead, we want to do maybe trials over here, just simply because we can recall it a bit easier. Replace this over here, even though I said I was just going to hard code it. Remember to spell it correctly and not name it trails. Okay, and now print wins out of trials for your win rate. So assuming we did this game. Oh, and I need to feed it what the win ratio, what the sequences are. Head, head, tail, head, head, head. Win is not associated. Right, wins. And let's turn off the printing statement, otherwise it's going to take forever. Okay, and so the odds of you winning this game, if we play it for this particular two chosen sequences, is 24%, less than a quarter. Now, why is this? Because really the only way you can win is by throwing head, head, tail, or is by throwing two heads in a row off the bat. That is the only way you can win. Because as soon as you throw a tail, then your sequence stops and my sequence begins. My sequence ends where your sequence begins. That means that I get to my sequence first before you do. So the only way you can do that is if you start the only way you can win is if you start your sequence first. I told you, it's a troll. It looks like it should be fair odds, but it's not. And, you know, the computer proves it. It's not a fair game at all. Okay. Speaking of not, now let's go to games that are fair, not fair for different reasons. So first off, in the board game Monopoly, first off, actually read the rule book. If you next time you play Monopoly, there's none of this, none of this collect money for free parking business. That's just simply to extend the suffering. Monopoly can be a brutally quick game that gets a completely runaway winner. That's kind of the point of Monopoly, where a person becomes a runaway winner. Okay. Players move about the board. So anyway, one of the ways, one of the rules of Monopoly is how you move about the board. You move about the board by rolling a pair of six-sided dice. Okay, you roll dice, you move forward that many spaces. So somewhere between 2 and 12, as described by bell curve. Rolling doubles, which is 2 3s or 2 5s, that's great because you get to roll again. Essentially, you get to take an extra turn, even though it's still your turn. Basically, you get to move more. Okay. If a player rolls another pair of doubles, if you get 2 doubles, you get to do it again. So you can get like 3. Now, if you are so fortunate as to roll doubles a third time on your turn, that's where your luck runs out. And actually, that's not lucky. You get sent straight to jail. Okay. Thus ending the turn, and you're trapped in jail until, guess what? You can roll another double, which is actually pretty funny if you think about it. So what we want to know is how likely are these outcomes? We're going to simulate 100,000 Monopoly turns. So extra rolls due to doubles, they're on the same, those are the same turn, by the way. So so a turn is a single roll of the dice or more until you roll a double. Your program should print out the percentage of rolls without a double, the percentage of rolls with 1 double, the percentage of rolls with 2 doubles, the percentage of rolls with 3 doubles. Okay. So there's a bunch of ways to keep track of those percentages. You could totally keep track of it in a dictionary if you wanted to. Or you could just simply have, a variable. But what we'll do is I think we'll worry about that later. What we're going to do is first simulate a turn. Points will be given as follows: 10 points for simulating the 100,000 dice rolls, 5 points for handling whether or not you get your doubles. It's actually very easy out for points right here. Simulate those dice rolls. Handling doubles, handling 2 and 3 doubles in a row, and then presenting the data points as a percentage. So not too bad in terms of breakdown of points there. Okay. And yes, because it's a common enough question, yes, you can, if you roll 2 3s and then roll 2 3s again, that's a second double. Okay, so first thing we need to do is we need to establish what our random variable is, or what our random factor is here, and that's a dice roll. I'm going to just simply call it a D6 over here for a 6-sided dice. And here, what I'm going to do is I'm going to return random.randint, which gives you a random number inclusive. This is the only time we use inclusive range in Java, sorry, in Python or Java or any programming language, which is when we're doing random numbers for some reason. I don't know why. It's just is. So that returns a random number. Def. Def monopoly turn. Okay, now here is the main thing that most people that I see that gets to be I see an issue sometimes with this where basically again where I get like roll 1 is equal to D6, and I see some, and I can't remember the exact error over here, but sometimes it's just checking if 2 D6 rolls are the same, and then and you're doing your D6 rolls where you shouldn't. I can't think of the exact wrong example right now, but just be note of how I'm keeping track of the variables. So roll. So first off, if D6 equals D6. So here they're separate dice rolls, right? I'm saying if one dice roll is equal to another dice roll, congrats, I just rolled a double. Otherwise, let's go ahead and return 0 to indicate that we rolled 0 doubles. Make sense? So we'll return the number of doubles we rolled. This will actually make it very easy for us to keep track of our results as we tally them up. Okay. So if we roll a double over here, that's great. And then if D6 is equal to D6 again, here we roll 2 more 6-sided dice. Okay. Then we can say pass again. So if we roll a pair of dice and we roll another and we get a double, and we roll another pair of dice and we don't get a double, we rolled 1 double. And then finally, if D6 is equal to D6, we roll yet another pair of 6-sided dice, return 3, else return 2. Looks kind of nice and symmetrical almost. Surprisingly easy to code there. Okay. Or concise, I should say. Def sim monopoly and same deal over here. I'll borrow this code over here, but we're going to need to change it drastically. Instead of printing out our wins, we got to keep track of our results in a more interesting manner. So what I'm going to do is I'm going to make a list with 4 indexes in it. 0, 1, 2, and 3. Index 0 will hold the number of times I got 0 doubles. Index 1 will hold the number of times I got 1 double. Index 2 will hold the number of times I got 2 doubles, and index 3 will hold the number of times I got 3 doubles. I could do the same thing with the dictionary, but it's simple enough to do here with a list. Okay, and so what I do for that is I say monopoly for range and trials. I'll do monopoly turn. And this will be a very interesting statement for a lot of you to see. Monopoly turns, roll it, that is a very interesting statement, right? I broke that up. So what in the world? So here I'm saying, take this number, it's now an index, and increment that index by 1. Let's go ahead and break that down into something a bit easier that will be the exact same thing. Okay. Num doubles is equal to the result of running the monopoly turn. Store that in there. And then we take the number of that index and increment it by 1. Generally, it's I personally feel like it's bad practice to have tons and tons of, to have parentheses nested in brackets. It's not, doesn't really look good. So now for our outcome, what we'll do is we'll simply say print, sorry, for I in range, for in range length of results, print I results I, and then I'll make it look nice by saying sep is equal to tab and there sim monopoly. Yes, once again I forgot the colon when I was writing the function. And oh, the last thing it wanted everything as a percentage. So trials. So 83% of the time nothing special happens. 14% of the time we get a double. 2% and 2% of the time actually we get 2 doubles, and a third of the time, and you have a 1 in 200 chance of rolling 3 doubles in a row. If we check our math for a second, 1 out of 6, let's do 5 out of 6, which is 83% is so basically there's 36 possible outcomes of rolling 2 6-sided dice. 6 of those 36 outcomes are doubles. So the remaining 30 out of 36, or 5/6, are normal rolls. So this is fairly close to what we would expect for our normal rolls. That logic does kind of make sense. And these are exclusive of each other, so this should all add up to around 100, or sorry, 1.0. Okay. Dictionary problem. Given a string, write a pattern that returns the most common letter in the string. Use a dictionary to do this. Okay. So this is a classic problem for strings and for dictionaries, which is asking you to find the most common thing. It's 2 parts, counting and figuring out what was the most common thing you counted. Okay, so def most common string, the most common letter. Okay. Text. Okay, and we will go ahead and give ourselves a test case. Quick brown fox jumped over the lazy dog. Okay, so there we go. So now what we do over here is that we've got some text and we're going to go ahead and I left out spaces intentionally in this case so that we don't have to worry about counting spaces over here, so we can see what we have. The most common character is almost always going to be a space, so but you can't exactly see your space. So let's go ahead and create our dictionary. I'm going to call it D for our dictionary, and what we do is we say for letter in text, if letter in D, if we've seen this letter before, then great, we've seen it. So actually let's go ahead and do it the other way. if we've not seen the letter before. If letter not in D, then we say, that basically says, we haven't seen this letter before. Well, we've seen it once now, great. Else, we've seen this letter before, so we should totally say, so we should increase that. Letter plus equals 1. So if we've not seen it before, it's 1. If we've seen it before, increment it by 1. Let's go ahead and check on our progress. Our progress says that we can count letters. There's 4 O's and 4 E's. Let's go ahead and make that a bit more obvious as to which one we should do. It's a long dog with 2 letters, so there we go. Okay, so now we have to figure out which one of these is the most common. So I'll just create 2 variables. Most common letter. I'm going to make the most I'm going to assume, so I need to initialize it to something, and something that exists in my dictionary. It's just typically the hardest part of this problem, to figure out what you should initialize this part to. So I'm just going to simply say that it's the very first letter of text. I'm going to assume that this is the most common thing I've seen. That this is the most common letter. Okay. And so now what we say is, for letter in not the text, but in our dictionary. If the number of times I've seen that letter is greater than the number of times I've seen the most common letter, thank you, copy paste, then that letter is now the most common letter. Right? If it's seen it more times, well, then that has to be the most common letter. And now return most common letter. Print. And that should give me O, which it does. If I change this to be a bunch of 1s in front, it'll tell me that it's 1. Just wanted to speed through that one because the last one I think was a bit of a doozy. Yes, it was. It was Dungeons & Dragons. Okay, so we've got 10 minutes left, so I've got to teach you all Dungeons & Dragons about 10 minutes. No, I just got to teach you. So really what it is Dungeons & Dragons has a game that has become less and less mathematically inclined as it goes on, which is good because honestly, I want to play games for stories, not to do the math. I have Stellaris if I want to do math. So D&D is very popular. And the idea here is that we're going to simulate the chances of first level fighter in 5th edition can slay a goblin in 1 hit. What do we need to know to answer this question? Dice. First, Dungeons & Dragons uses dice and basically uses dice modifiers to figure out whether or not something actually occurs. And this is not used for every action, although it does seem like that in some like playthroughs that people do. That's just a sign of not great DMs. The idea here, though, is that that for things like attacking somebody else, that always has a chance to it. So we roll a 20-sided dice. In other words, it has a 20-sided dice has basically the results instead of being 1 to 6, 1 to 20. And often we'll use a 6-sided dice as well, which we just simply call D20s and D6s. That's standard dice notation. The dice notation looks as follows. 1d20 plus 5 means take a 20-sided die, add 5 to the result. So that would effectively give you the range of 6 to 26 because you've got 1 to 20. Actually, to give you the range of it would be 6 to 26 exclusive. So it'd be 6 to 25. Okay. Good job, me from the past. Good job messing up the base of math. Anyway, 3d4 plus 4 means roll 3 6-sided dice, add their sums together and add 4 to that, which gives you the range of 7, rolling 3 1s and adding 4 to that, or rolling 3 4s and adding 4 to that. 8d6 just simply says take 8 6-sided die, roll them and add them without adding anything up, gives the range of 8 to 48. Okay, so how do we use that? Combat's basically broken down into two parts: attack roll and a damage roll. Attack roll says, did you hit or not? And anybody who's played any kind of game where there's a chance of missing knows that you miss 90% of the time and the enemies hit 100% of the time. Especially when your guy's like 1 point away from death and it's a permadeath game. So, you know, even more there. So the attack roll is made to see if an attack hits the target. You do this by rolling D20, adding your number. And what you have to do is just simply see if that number is better than the target number, which is called armor class. So here is an example, trying to blast a zombie, which can't dodge. They have a fairly low armor class of 8. My wizard's attack bonus is +4, so I roll 1d20 +4. If you roll a 7 or better, congratulations, you hit. Otherwise, and you get to do damage. Otherwise, you miss. Damage. See, basically, we see how much damage we do. So this is much simpler. There, you just simply roll other dice. You simply take the dice, add the bonus defined for this attack. So for example, if you hit a ghoul with his mace, that might do 1d6 +2 damage. That is a range of 3 to 8. Okay. The damage is subtracted from your target's hit points. If you reduce the hit points to 0 or less, you've killed it. So our simulation is we're going to simulate a first player, a level 1 fighter, attacking a goblin, which is a very common monster. So the fighter's attack roll is 1d20 +5. The goblin's AC is 15. If the attack rolls hits, the fighter's damage roll is 2d6 plus is 2 6-sided die and 3. A goblin has 7 hit points. Calculate the odds of a fighter slaying the goblin in a single blow by simulating 100,000 attack rolls and the respective damage. All right, let's go and quickly do this. I breezed through that. I also know that that some of you were like, this is boring, which is perfectly fine. But the point being is I wanted to see if you could, the challenge for this one is reading a long wall of text and getting out the information I had strewn in there. Okay. So D20, we've already created a D6. So what we're going to do is we're going to say, we're just going to return random.rand int. And personally, I find Monster of the Week to be my new favorite RPG system of this. Less dice rolling involved. Okay, death. D20. And now let's go ahead and simulate an attack roll. Death. Attack. The attack is so we're going to simulate actually the attack roll and the damage roll in the same basically let's just call it attack. We know what the fighter's attack is. It's 1d20 +5. So if 1d20 +5 is the d20 +5, that's our attack roll. If that's greater than the goblin's AC of 15 equal to, that means we hit. That means we can roll for damage. We said the damage is code a function to make an attack roll, code a function to make an attack roll hit. We did that. Damage, 2d6 +3. D6. This was the thing I would see. Yeah, don't do this. It's 2 different 6-sided dice. Not D6 plus D6 plus 3. That's how much damage we would do. Otherwise, if it's a miss, you return 0. There you go. That's it. That's the sum of all the rules that that you had to sift through. Okay, death. Sim attacks. Actually, no, we were seeing if we could slay a goblin in more than 1 hit. So now we have to return one other thing. Greater than or equal to greater than or equal to 7. Did we do more than 7 damage? Otherwise, return false. Sim attacks. If it's not actually, again, this is wins is equal to 0, trials is equal to 100,000 for in trials. Yes, that variable name really rolls off the tongue. Or okay. Sim attacks. If attack wins plus equals 1. Wins divided by trials. Which should be, now this should be fairly 50-ish%. Yeah, 50-ish%. Yeah, this is a question I asked on the final exam at one point. Doesn't require much code to do it once you understood what was going on. But for a lot of these Monte Carlo problems, it's a matter of reading what's going on and making sure that you're doing the things. After I did that, I'm like, yeah, maybe that was a bit much, even with the final exam and the amount to read. Because I gave good examples with this, but honestly, it's a lot of moving parts in 2 stages. But once you break it down into the code, it's not that hard. I admit that was one of my poor questions, but it was a question that existed, and thus I gave it to you. Now, again, for this one, it is, yes, definitely going to be of the format. Professor Rosen wants to play a game. He says that you've got a fair chance of winning, and he's lying through his teeth. Figure out the real odds of the game. I urge everybody, I know that some of you are saying, I've been discussing, okay, I like my first 2 exam scores, so I'm not going to take the 3rd exam. Honestly, you should just go and take it anyway, just so that you can just because it will be good practice for the final exam. Yeah, because that switch over from the idea of not taking it to, I don't have to study for this because there's no pressure, and just take it. Because honestly, again, it's your choice as to this because of the way I'm working. I'm probably going to switch over to, in the fall, just doing 2 exams and a final, which I find to be a bit more doable. Now that being said, I should mention that the 3 exams and the final is a very different thing that does not get dropped. The only way you get out of taking the final is if you get one of the best projects. So just to be clear about that, okay? So you can't skip the final exam. I'm saying that, and I'm probably gonna have to say it multiple times. Okay, so all right, class dismissed. Yes. The final project is due at 11:59 p.m. on May 1st. It has a very, very steep late penalty where it is 1/10 of a point off every minute late. Because I cannot, and this is to highly emphasize the fact that students need to turn it in. I do not do late. The only way it's going to be late is if you have an incomplete. So that is the only way I'm accepting late submissions for that final project.
Let's do the exact. First, can I demo my pig lab?